right? So let's see how each of the collection item works. So let's start up with the basic declaration, and let's see how the collection items normally work. Again, as we have seen in arrays, right? Again in collections, so we have to follow three different rules which are mandatory. So declaration. So the first step will be you have to declare your collection array variable, right? And then instantiate it. So we have to instantiate and then initialize. So these rules are common again even for collections, right? As we have seen in arrays, right? So what is declaration? So this is something which is declaration, right? And this is something which is instantiating, which means you are actually constructing an array, right? And whenever we start defining values to this, right, that is something which is a initialization of your array, right? So that is the three rules which we normally follow. So until unless you build it, right, you won't be able to initialize. Now, if you try to initialize without building or instantiating it, right, then it will give you a null pointer exception. Okay, cool. So let's start up the sample collection program and see how it works. So let me create a new project. We call collections. Let me make it as a startup project. Right. Right. So let's take up the first one, which is our array list. So and see different things. So again, when you take array list, right, so we are actually considering the collection item. Now you can see by default you have your collections being actually imported, right? Or we are using the collection namespace which is under system already been used. But you can see it actually imports the generic one, right? But yesterday we have actually understood that there are two types, which is the non-generic collections and the generic collections. So if you use a namespace called system.collections.generic, then all the generic way, I mean whatever collection classes which are supporting generic collections will be can be used, right? So in order to use non-generic, then let's make it just collections. System.collections, so whatever are not required, you can just remove them, right? So system.collections, this will have all the classes which are non-generic. So you can see we have an array list. So array list is a class under system.collections which is a non-generic collection item. So main declaration is you have a class name and the variable name. Let's say it's obj, which is a declaration of a collection item. And then how can we instantiate? Say for instantiating or constructing an class object, right? We will be using new keyword and the class name. Now this is how we normally declare a collection item. Right? We have array list, obj, which is a variable name or object name, and we are instantiated with array list class. Right? So this completes a building or instantiating our collection item. Now you can see the third step is to initialize the data, which means how can we actually feed or retrieve or work with the data elements in this collection item. So first let's see how we can actually feed data, right? Now here you don't have to go for indices, you have something called internal classes of your collection items, right? You can directly go for array list, which is object obj.add. Now add is an internal method of your collection item array list. Now, whereas when we used to use arrays, how do we initialize the data? You have to remember the index and then you have to provide index here. Let's say you are actually adding third value, then you normally provide I of 2. So it's something. Now this will be your value, right? So here just add it. So here you can see when I click on add and restart, right? Here it says add object value, right? Now this was our first learning that collections supports holding multiple type of objects in its memory, right? We don't have to add only when you declare int array, we have to add only int array, but here we can actually add anything. Let's say I'm adding some string first, right? And then let's say I'm gonna add some number like integer as such. So I'm going to add some decimal or double value. Same way I'll add some float, right? I'll add some actual decimal data type. Right? And you can add anything. Let's say add or let's say you want to add a character, you can add. So there is some questions. So we don't need codes for the numbers in object. Just want to make sure. We don't need codes. No, we don't need codes, right? It's only for character we need only for character we need codes, right? For number you don't. Now if you yes, correct. Only for strings we need codes. So for number, if you start making codes, right, then it is not an integer or it is not a number type. It's a string type, actually, which means you are actually providing a string to this object, and string contains all numbers. That's it, right? So this is how we feed data into a list. Right? Adding any object. Okay, perfect. So adding any object into array list, right? So this is how our collection item supports accepting multiple objects. Same way, right? Whenever we want to retrieve data, it gives the same support. Now here, for retrieval part, right, we will be using, same for each loop, which we have already seen. Now for each loop is mainly designed for collection items, basically, right? Now as we have something called the link, which we'll be learning in our upcoming classes, right? Link for mainly link to SQL and link to mainly entity framework whenever you are writing, right? Mainly to actually, you will actually get the data from database to some collection item. It can be list or something. On top of that, we'll be actually using a link to actually filter out data even in a granular level, right? Same way here, we have a for each loop where you can actually make iteration to this array list and actually get the data. Right? So let's see how to do that. Now, even before that, we have some internal properties of array list class, right? Let's see what exactly they are. Now, we have something called, let me print the properties. Let me mainly print that line of, let's say obj dot, we have one property called count. Count will give you the number of items you have or number of objects you have in this array list. Console.write line of, let me just rekey. Right? So number of items in the sense the objects you actually added to this. Again, whenever you remove anything, right, it automatically sets the indices, right? Anyways, internally it is actually following the same array pattern. Apple will be in the 0th index, same way 1, 2, 3, 4, 5, 6 and so on. So whenever you remove anything, right, then the indices will be automatically arranged internally. You don't have to worry about removing the index and rearranging all the items, right? That's how it actually works dynamically. And the count will actually give you the number of items here. Let's run this first program and see how many items do we have. You can see it's a 7, right? So there are 7 items in my list object. Fine. Now let's go and see other properties if we have any pages. Obj dot. So you have other property called get. Okay, fine. I think you can actually now you have these are all property we use. We have more classes as of like reverse, remove. What we'll see that. Fine. So before that, let's retrieve the data. Let's read the data from object value. Now here, 2 things. You can use both for loops which we have to read our list. So which means let me use a normal for loop first, where we have index, how to read with respect to index here. Now again here, while creating a for loop, we have declared I is 0 and I less than. You can't actually hardcode the value as 7, right? So it can be dynamic again, which means again you have to make your for loop dynamic. Now, how can I make it like how much is a count? Now, we just understood that we have a property called the count, which I can use here, right? Which will give me whenever we have an addition of item or removal of item or removal of a range of items, right? We will have, whenever it comes to for loop, we have a right count, true count here, and we are actually iterating through the true count. Right, so this is a loop. So let's print the items. Now how to read again? Now you can see you can actually read array list even as if you are reading a int array. As an array, right? Where you can actually provide an index. So let's say I'm going to take it as I. I is again an index. So as I said, even in array list, right, your items will be saved internally as an array. Right, so this is a source of truth. Now let me run this. Now you can see the count is 7 and all items which we actually fed we are getting as this. Right, so this is using your actual for loop you should normally use. So let's use a for each loop. So in for each loop, the syntax is that for each is mainly used to iterate through collection item, right? Now, anyways, we are in collection item obj, so we'll give it as obj here. Now, where is nothing but an object type of variable, right? Now, you can actually assign any data type to where variable, right? So to be more specific here, what is that object accepts here, which is my array list. Array list accepts any object, right? And moves over, you can see. Now it accepts any object. So here, let's make it object. Even if you actually keep it as where, it will work. Where can take any variable. It can be object, it can be string, it can be integer, double, boolean, integer, a short, anything. Right? Now which means now we are iterating through each object in my main collection item on obj. Right? And every iteration, new element, whatever the new item is there, will be assigned back to right. That's what happens. So let's print that. Okay, now here we don't have to worry about which index actually we are working on. Right? It's a brand new thing which we are getting. So recline out. So this is what we have. So let's run this. Now you can see we have both the items, both the ways how we read this say. Right? And again, whatever pattern we are actually using here is common for all collection items. Whatever we are going to see, right, will be same, except for few. Right? So this is your array list where I'm using for and for each. Now let's see how to remove data. So here we have an element called, for remove you have few methods here. You can remove, so direct remove is nothing but removing a specific object. Like let's say I want to remove this 211, right? Now if you provide a remove method, right? So this will actually take the object as such, right? And this object will be removed from 211. So let's run this. You can see we have 211 here in our before removing, and after removing you can see the 211 is not there. Now which means you have removed the complete object from this. Same way we have one more thing called remove art. Remove art is it'll actually seek a index from you, like which index you want to which index object you want to delete. Let's say I want to delete first index from you. Right? Now what is there in first index? You have 2323. Right? I run this. You can see the apple 2323. Now you can see that 2323 is removed and also your object is removed. Right? So that's how we can actually remove data. Now again you have seen one more thing, which is remove range. Now this needs, right, again from which index to which index you want to remove. This is your range again, right? So let's say I want to remove from second index, right, to how many elements? Let's say from second whatever I have I want to remove. So I can't give it as a count here. So after deleting, let's say I want to remove 3 elements. So already 2 elements are gone with these two, right? Let's say, and you have 1, 2, 3, 4 elements from 2. Let's say from 2 I want to delete 2 elements. I think this is a remove range, right? Now totally how many I am removing? 1, 2, and let's say 4. Let's run this. Now you can see you have total 7 elements where you removed actually 4 different elements. Now you have 3 elements left in your list, right? So that's how it works. Now whenever you remove anything, right, now that memory will be freed up from collection, right? And we have these elements in collection. So that is how we read and do different operations in collections. Right? Let's see other methods you have. Let's check out the reverse. Now let me just close up this. Now if you want to reverse your elements in array list, right, you can do that. We have an internal method called reverse, which will actually reverse the elements, right? So the way you appended your elements, if you want to make it reverse, you can see it actually reverses the complete set of elements, right? And then you have something called, let's remove it. So you have one more thing, which is your count elements you have seen. Let's see the clone. Now clone will actually give you an object again, right? Clone of the same. Now for every collection item or for every object in .NET, right, for most of them you have a clone. I mean, it is like getting a copy of what exactly you are working on now, right? Now the object clone will give you a copy of a new array list items tree. That's your clone, right? And this copy too is nothing but copying this existing one to a new array, right? You can actually copy all the elements of your current object into, if you have any other array, right, you can actually copy that. Either you can do direct array, right, or you can actually go ahead with different collection item. That is a copy tool. And then you have, I'm searching for one more thing, add range. Yes, this is what I'm searching now. Add range is nothing but if you have other collection item, right, any other collection item, you can actually give that input to this collection item. Right? Let's say you have a list, right? You can actually feed that list and give it as an add range. So all the elements will be appended to the add range. Okay? So this is something which we have a collection items and how we work with the different methods we have in Delta. Right? So this is how we normally use mainly the data retrieval, removal, reversing, getting count, and using different for loops to actually work with data. So there is something which we normally use mostly with the collection items. Yes, we do have one more thing called using link, right, where you can actually filter out some data, right, which we'll be checking out in our link topics. Now let's go to the next one, which is our hash table. Now even before going to hash table, right, because hash table is something which provides more specific things over here, like so it provides a different set than with other things, which is stack and queue. So first let's look at stack, queue, and then let's get back to the hash table. Right? Now, what is a stack? So as name conveys, right? Now stack is something which we have already, you would have already know this. Stack is always follows the last in, first out pattern. Right? The element which enters the stack, the memory at the end, right, will be removed first. Normally we call push objects, and whatever object being pushed at last will be popped out first, right? Which is the last in first out pattern. So if you, sometimes you may have to actually work to make a LIFO pattern, right? So in that case, you don't have to go for array list to actually add data and actually read from last index, right? You don't have to do that because we have a stack class which actually follows a LIFO pattern by specific methods being provided. So let's see the stack example here. So let me create a new class. So let me call it as stacks. So here let me create a static main method first. So here there is an error, let's catch it up. Now you can see stack here. Now whenever we use stack, right, again we can actually see that it is seeking for something else, right? In stack you have two different ways to define a collection item, right? Now here whenever I just define stack, I just give this method, right? Because I'm not using the generic I'm not using non-generic stack option, right? So now you can see it works. So let me take it as STK. So this is a stack class which we use, right? Now why do we need to specifically go for stack? Whenever you need a data operation, right, in the LIFO pattern, then we go for stack, right? Or else in normal situations, if you want to work with multiple collection items or a data element which you want to store, right, then you can actually go for array list. But if you want to follow some pattern to feed data and actually get the data back, then in a LIFO pattern, then yes, your stack is a right class you have. Okay. Now in this stack, right, you have few specific methods which are more specific to stack. Provided to actually make the LIFO pattern, right? Now the first one is for adding elements, right? You have a class or a method called push. Push is a method which is used to add data into stack collection item. To get the data, you have a method called pop. Pop is a method which is used to get the data. Now, whenever you pop elements, which means whenever you try to read elements, right? Now this pop will actually do two things. One is read element and remove that specific element. That is your pop, right? And then you have one more internal method called peek. Now peek is a read-only method which will read the value which will be popped out next time, right? So this is something read like top value which will be popped. So these are the three important methods we have in stack: push, pop and peek, right? So let's see those things here. Now let's first add the elements. Now which means you have to use method called push. Now again it says provide an object, right? Because we are checking the non-generic collection items. Non-generic collection item, any non-generic collection item will need an object input, right? So let's give some objects here. Now let me again give some start graphic. You have dot push. Let me give some number here. Anything. I can also give even the boolean value, right? Let's say we have these elements. Now, whenever you start pushing the element, right? Now it will go and sit in some index, right? When each and every a collection item you're adding will be arranged in a specific index elements. Now, whenever you start retrieving data, then what happens? It will actually read data from the last index only. Right? So, how can we read that? So, this is something which we have for pushing, which means we have already added elements to stack. Now, let's see how to read the data. Now, before that, let's see what is a peak value. First, let's see what is the latest value which will be popped out. Now, in my stack, let me get what is peak. Now this peak is nothing but which value will be popped out. So let's see what that first. So we have console.read key. Let me run this program. So you can see that you have all elements, right? Now you can see whenever I click on peak, right, it says your element which will be popped out if you use pop method is your true. Right, that is a peak. Now, let's loop on this stack, or let's see in this way. So, which will actually give you a much better. So, console.writeLine of. Let's say from my stack, I'm actually using some pop method. Okay. And after making this pop, let me differentiate with the peak. Now after copying one element, let me print the peak value. As I said, whenever you use a method called pop, right, what it will do? It will actually read the last inserted data and it will remove the data from stack. That's what happens here. Now before popping out, it will give you your peak, and after popping out, let's see what it actually gives. So now you can see here the peak was true, right? And when we pop, you can see here it removed true, and the next peak is A, right? Now you can see it actually moved. So that's what is the behavior of the peak. Now let's do pop like 3 more times. Now you can see here that it will remove last in, first out, right? So true was the first one, it's the last one added. Now you can see true removed, That's A removed, 1, 2, so and so removed, and 12 dot, so and so removed, and apple removed. Now you can see it follows a sequence from last to first. Right? Now you can see that now there are no more elements to pop. What happens if I use one more pop? Right? I'm just trying to pop an element where my stack is empty. Let's run this and see what happens. Okay, we already have a pop, one more pop. Okay, fine. I think we already had one element called apple. So let's pop it up again and then run this. Now it will give you error. See what happens. Let me run this. So till this pop, right, everything we actually remove. Till apple we remove. Now if you do one more peek, right, so now you can see it is an exception. Now it says that stack empty. Now this is your exception type invariant operation, right? So the operation which you are doing is not a valid because you have removed all the elements from your stack and you are trying to read your highest element, which is not allowed. This is stack empty. Now we can just case of either peek or do one more pop. You don't have to wait till peek. Just do one more pop. It will give you. Now again, after removing everything, I am trying to read. Now you can see stack is 0. Now if I do this, again you have an exception. It says stack empty. Fine. So this is how stack works. With your peek and pop, you can actually get the data, right, and remove the data in such way. So this is MD4, last in first out which you have. Right. The same way, let's look into the next one, which is Q. Now Q is your FIFO, which is first in and first out, right? So again, it always works in it follows the Q manner again, first in first out, right? The element which got added first in the queue will be the first element which will be called out. So here, even for Q, in order to actually maintain FIFO pattern, we have few methods. So for adding data, you have NQ. For actually reading data, you have DQ, right? And getting the highest element, again you have peek, right? So these are again three methods which you have in Q to actually make the pattern in a FIFO manner, which is first in, first out. So let's see the Q, how it works. So let me create a new class in the collection. Add a class, let me call it as a Q, and here let me add a static void. So here, now let's go ahead and see the Q part. Now here we have to use a non-generic collection item type, so I'm just removing that, and you have your Q class. Right? Let me make it as Q. Now again, this will accept as many elements as you want, which can be an object. Now you have QU dot NQ, right? What's up here? So since it is not recommended to use because this accepts a greater object value and you may have a few issues while actually retrieving or accepting data. But generics, right? In generic collections, you have something which accepts object or any specific data type. If you want to restrict to a collection item, you can do that in a generic collection. Now, your generic collections have more classes, right, which you can use. Right. Instead, I can say whatever are there in non-generic, right? Even all the classes are there in generic collections, including some more features, or including some more classes which we have in generic collections. Like we'll be checking out the hash table or IDX, right? So these are more, and mostly that we have to provide some generic next line what data type we want to use specifically, and then you can actually go ahead using that. Right? We will see the generic collections part in our next class. Okay, we got the solution, guys. So the queue, right? Why it was not actually accepting before was we gave the same name, same class name, same as queue, and whenever we were using that queue, it was actually referring to the class, and it doesn't have the values, right? So that's the reason why it was not queuing. Now you can see queue contains both the things. It can accept both non-genericness, right, and even the generic collections too. That is something which I was wondering. Good that we found out. So the class name was same. That's the reason why it was not. It was actually overriding the actual library provided with the class we defined. That's fine. Now you can see this is how we can actually enqueue data, right? Obj.enqueue. Let's say we have one obj.enqueue. Let's say we have some more data, right? So enqueuing will actually add details into queue, right, and it will keep an eye on the arrangement. Now, first element will always stay in first, second always stay in second, and all, because it has to follow some pattern. Now, this is something which is the addition of or adding data into queue. Now let's see the first peak element which I will be getting, right? Let me just print to our highest element as such. We have obj dot here peak element will actually be what element will be removed. Okay, not a problem. So let's run this now. You can see the first element which will be removed is apple, because first element which we added is apple. So first in, first out. Apple will be the first one. Right? So now let me use DQ now. Again, your DQ will give you what exactly you are reading. Now let me check what as obj.dq. And then again print the peak element. What will be the next peak element? Right? Now you can see apple was the first peak. It removed apple, and that's the first element which we had, and then it gave 2 and 3 as an next. Fine. So that's about it. Now again you have, let me DQ it again. Now again you can see DQ 2 and 3, and you have 9 seconds. Next peak element. Again remove, DQ one more element, and then I'm using another peak, right? Now when I run this, now you can see it actually removed everything. The 9090 was the last element it removed. Now again, one more step you do, because now you can see obj count is 0. You do any more operation here, again it will give you an error, right? When it says your queue is empty, again it's an invalid operation exception. Now this is your this is the behavior same as the stack which you have seen. Right? Now this is how queue works. The first in, first out way. Fine. So these are all the non-generic collections which we have seen till now. Right? So in tomorrow's class, let's check the generic collection items, which gives more specific restriction to the data types.